Hello friends, this question is from the subject of network and topic name is 2-pole network. In the problem we have three coils. First and second coil has been coupled with a magnetic coupling of zero point 0.5. First and third coil is coupled with a magnetic coupling of 0.2. Okay, so friends, we know that the magnetic coupling generally in the textbook it is denoted by the M. Here it is given as a K1, which is 0.5 in the case of coil 1 and coil 3. So we know that the coefficient of coupling K is related to the magnetic coupling M, as K is equal to M upon root of L1 and L2. In our case, the M is 0.5 and L1 and L2, if you can solve, will come out as 100. So if you can do the calculation, you will get the coefficient of coupling is J50. Similarly, in the case of in the case of coil 1 and 3, you will get the same coefficient as a J20 ohms. Okay, so now if we draw the equivalent circuit of the this electrical network, you can see that the coefficient of coupling between coil 1 and coil 3 is J50. It means that with respect of the source current I1, if in the first coil we have a current I1, let us assume in the second coil we have a current I2. Similarly, in the third coil we have a current I3. So because of the current I1, we have a induced voltage here in this coil is in the magnitude of J50 I1. Similarly, because of this I2, we have an induced voltage in the coil 1, which is J50 I2. And similarly, because of the source coil 1, we have a voltage in the coil 3, which is J20 I1, because the coefficient of coupling between coil 1 and coil 3 is J20. Similarly, because of the current I3, because of the coil 3, we have an induced voltage in coil 1, which is J20 I2. Right. So now we have these four voltage sources. Now if I may draw the equivalent circuit diagram of this network, it will be equal to we have an inductor as always. Now we have one voltage dependent source, we have another inductor, we have another dependent source, and we have a source generator. Why not? Similarly, in the second coil also we have a dependent source, we have an inductor and load resistor. Okay, now here also we have a similar thing in the case of third coil. Now if I can write down the numeric values, you can see that the source voltage is still 100. We have a coil of J100. Now we have induced voltage of minus J50 I2. Okay, why minus J? Because the direction of the voltage polarities has to be inverted. It has to be minus plus, which I have drawn in plus minus, that's why it's minus 50. Now it is J100, and here again minus J20 I3 plus minus, this is the same polarity which I have taken. Now here this fashion, here is J50 I1, J100 10 ohm plus minus J20 I1 and J100 20 ohm. This is loop 2, current is I2. This is loop 3, current is I3. This is loop 1, current is I1. So now if I may write them down, because we have three meshes, we can write down the three mesh equations. So the first mesh equation will be, if I may write the mesh equation in the loop 1, it will be 100 is equal to J100 I1 minus J50 I2 plus J100 I1 minus J20 I3. Similarly, in the mesh 2, if I may write down the equation, it will be 110 plus J100 I2 is equal to J50 I1. So now in the mesh equation 3 is 0 is equal to 20 plus J100 I3 minus J20 I1. So you can write it down the equation number here. This is my equation number 1. This is my equation number 2. This is my equation number 3. You can see we have 3 equations and 3 unknown. I1, I2, I3 is 3 unknown, and we have 3 equations. So by simply solving, we can get the value of I1 as 0.5833 in magnitude, and the angle is 88.92 minus, and the current I2 will be 0.2902 and 83.2, and similarly the current I3 will be, you can write down here, current I3 will be equal to the 0.1144 angle of 77.6. So now we need, in the first problem, we need to calculate the power delivered by 10 ohm resistor. So across the 10 ohm resistor we have a current I2. So power delivered by the 10 ohm resistor will be I2 square into 10. So it will simply I2 square into 10. The value of I2 we have just calculated, magnitude is 0.29, square into 10. So the answer is 0.842. And in this case the correct option is option B. Correct option is option B. No. In this case the correct option is option C, 0.84 watt. And the third case, in the third problem, we need to calculate the power delivered by the source, power generated by the source. So power generated by the source will be is source voltage 100 into source current, and the source current is I1. So the power generated by the source will be source voltage into source current, which is 0.58 cos 88, sorry, because the I1 is 0.5832 into minus 88 degree, because here I am applying the IRMS into VRMS formula. In this time we have applied I square R formula. We have a source voltage and source current, so my value will be equal to 1.1 watt. So the correct option is option A, which is similarly equal to the 1.1 or 039 watt. So in the first problem the correct option is option C, in the second problem is option A. Thank you.